Welcome to this 7th in the series of videos on refraction through lens. In this video, we look at a use case when an object is between focal length and 2f. So let's quickly see the ray diagram for this use case. As we move the object from focal length, at focal length the image is at infinity towards 2f, we see that the image also comes closer to the 2f from infinity. It's enlarged and inverted. So let's quickly see a demonstration of this use case. We can see this image of the filament at infinity for bulb source, which is quite far away. Now the lens is at approximately a focal length distance from the bulb, and in this case that distance from this bulb to the lens is approximately 10 centimeters. Now you see these two sticks, and the distance between these two sticks is 20 centimeters. So this lens is approximately halfway between these two sticks. As we move this lens from 10 centimeters mark to the 20 centimeters mark, you will see that the image will come from the screen, which is very far away, and will fall down rapidly, and it will come towards the 2f, right? So let's see what happens as I move this lens a little bit, slightly, a tiny bit, and let me show you the image. First, let me move the lens tiny bit, and you will see that the image is no more there on the screen. It's quite blurred, so we have to find the new position of the image. So we'll find the new position of the image by using a screen. So you have to bring the screen till you find the rings of the filament very clearly. So that's what we're doing. And yes, bring it forward, bring it forward, bring it forward. Yes, or a little bit forward. Let's see the blurredness. Let's bring it forward even further, even further, even further, even further. So let's bring it to a point where there's blurred. Yes, it's blurred. It's no more clear. Now take it back. And this is a process of capturing an image. You bring the screen first forward, and then till a point where it's blurred, and then slowly take it back to a point where you start seeing the rings of the filament very clearly, as you can see here. We just saw in this demo that this object distance was equal to minus 10.5 centimeters, though it's on the right side here. Okay, so let's not put sign here, but this was 10 centimeter, 10.5, and this image distance happened to be, or we need to find what this image distance is. Now the ray diagram for this would be as follows. If the object is between f and 2f, let's take a representative point and draw the ray diagram for this. So let a parallel ray go to the lens. That ray goes through the focal point, and another ray through the center of curvature goes straight, undeviated. So the image would be formed beyond 2f. That's where the image is formed. So this is I and this is O. To find out where this image is formed, in this particular case, the U is minus 10.5 centimeters, and given that your focal length is 10 centimeters. So let's apply lens formulae. 1 by V minus 1 by U equal to 1 by F, or 1 by V minus 1 by minus 10.5 centimeters equal to 1 by 10, or 1 by V is 1 by 10 minus, or minus of minus is plus, so we bring this side, it becomes minus. That's 0.5 divided by 105, or V would be equal to 210 centimeters. So that's V. So this is image distance is 210 centimeters. If your object height is 5 centimeters, we can find what the image height would be. Image height would be magnification into object height. The magnification is given by V by U, that is 210 divided by minus 10.5. Let's use a calculator. 210 divided by 10.5 is equal to 20. So the magnification is 20, or rather minus 20. So your image would be equal to minus 20, which is magnification into object height, which is into 5 centimeters. That's minus 100 centimeters. So we see that the image is the image that is formed is enlarged, it is real, and inverted. I urge you to reproduce your learning goals in your notebook and see if you can recollect all that you saw, the visual demo, the ray diagram, and how to apply the lens formulae, and putting the numbers and trying to find the magnification. So I hope you enjoyed this video. See you in the next one.